Okay, welcome back. Hopefully I have some sound now. If somebody wants to drop in the comments, about 10 of you popped in and said no sound. So hopefully we've got some sound now and we'll get back to the real live stream. So let's just say we're starting from here. Welcome everybody to Thoughts from the Field. Thank you for joining me, hopefully with sound this time. We're going to talk about the fact that it's just really hot out. It's supposed to be 117 degrees here where I live. I think that's about 47 degrees Celsius for those of you outside the U.S. So it's really hot. It's hot to even keep the studio cool. So we're going to talk about that a little bit this morning. But before we get started, I'm gonna pop some news up here on the screen. Some good news this week. We've been talking here in the U.S. a lot about infrastructure spending and a possible infrastructure spending bill. We've got a tremendous need to upgrade and improve the infrastructure here in the United States. But I picked this news story because I thought it was interesting that this particular piece from forconstructionpros.com tied infrastructure spending to commercial construction. So they're really predicting that even a modest infrastructure bill passing will send commercial construction soaring here in the U.S. in 2022, with probably they're saying about a 10% gain in 2022. And one of the things that I thought was interesting in this article here was the fact that warehouse construction was up 6% last year, and seems like it'll be up another 8% this year, another 7% next year. So perhaps that has something to do with improving the supply chain that Daniel Stanton and I were talking about on this program last week. Tied to commercial construction soaring and really all construction segments soaring around the world, we've got another bit of news here out of the UK. This is from Construction News UK, and they're looking at labor availability worsening as vacancies hit a 20-year high. And this is really a problem. Again, illustrates the problem in the US, in the UK, but it's clearly a problem here in the US as well. We continue to see a real strong need for labor, skilled trades, really all types of jobs in the construction industry. And I know I talk about this a lot, but I really encourage all of you in the construction industry, really in the AEC, any of the AEC industries, architecture, engineering, construction, continue to promote things like the fact that skilled trades are an absolute legitimate lifelong career. I went to school to be an electrical engineer, but I worked construction to get my way through it. And when I was done, I decided electrical engineering wasn't for me. I stayed in construction, and I've made my way, really through the construction industry and many different career paths, from labor out in the field to concrete form setter, instructor. I've worked for a couple of trade associations as a technical advisor. There's a lot of opportunities in construction, whether it's skilled trades or something else. And we really need to continue to promote that and open up opportunities, internships, and things like that for people in construction. I've said it before in some of my courses, on some of my other live streams. I'll say it again. I really believe that one of the untapped markets for labor that we have in construction is women in construction. Women make up a very small percentage of our workforce in the construction industry right now, and we really need to do more in the industry to improve that, make this a more inviting opportunity, a more inviting atmosphere for women in construction, because that's really a market, a labor segment that we have not tapped into, and we need to if we're going to solve some of our labor shortages. So, keep that in mind. With that, let's talk about working out in the field and the fact that again, it's just really hot. I've always found it interesting being in construction that when you go to areas of the world, areas of the country that have cold weather, They absolutely talk about shutting down because of not just snow, but the fact that it's so cold out that they can't work. And they sort of recognize the fact that cold weather impacts whether we can work in construction sometimes. I've never worked in cold weather like that for any length of time. I've always worked kind of in the southwestern portion of the U.S. in very, very hot weather. And from my recollection being out in the field, I don't remember a whole lot of days where we just stopped working because it was too hot out. We had a lot of days, because we were in the concrete, I was in the concrete industry, I had a lot of days where, we'd start really early and finish before it got too hot. But, it was always just this very subjective thing. It seems like it's hotter today than it was yesterday. It's not a good way to plan for the heat. One of the things about working in the heat is that, the heat really can have an adverse effect on our bodies. It can really cause a lot of problems, up to and including death and fatalities. And we absolutely have those here in the US and around the world. People just overexerting themselves, whether it's work, exercise, training, whatever, overexerting themselves and getting their bodies to what we call heat stroke, which is can be a fatal condition. And I'll run through heat stroke and some of the other heat-related illnesses and signs and symptoms here in just a minute. I'm going to go through those fairly quickly, though, because I do have a full class here on LinkedIn Learning on working in the heat. See if I can throw a link to this class, or a shortened link to this class, up in the stream. Yeah, so there we go. I've got a full class on working in the heat here on LinkedIn Learning. It really goes through the types of heat illnesses, the signs and symptoms, and I spend the second half of the course really talking about a way to develop objective criteria for determining what you need to do each day to keep people safe as they're working in the heat. Again, as opposed to just walking out and saying, wow, it's really hot today, or it seems hotter today than yesterday, because then you throw humidity in the mix, and that can really have an adverse effect on the body. So that's one of the things I really spent a lot of time in this course doing, is going through a way to create a very objective set of criteria for what you need to do each day working in the heat. And I'm gonna go through a little bit of that here this morning in the live stream. So let's give me a minute to queue up some slides here. And let's go ahead and talk a little bit about the heat's effect on the body. We'll pull this banner off here. Heat does a lot more to the body than just, wear you out or cause sunburns. And the bullet points that I've got up here kind of explain it. The body generates heat internally, just as part of the process of keeping your body moving. And it's important for the body to get rid of that heat. It moves heat from your body's core out to your skin. When it's really hot outside and your skin is hotter than the core temperature of your body, it really starts to stress the body as the body tries to get rid of heat. Blood vessels near the skin increase in size to help offload that heat from the body. When those blood vessels increase in size, the heart has to work harder to pump that blood to the skin. Ultimately, if the body can't rid itself of heat fast enough, your core body temperature rises. Now, there are varying degrees of what we call heat-related illnesses. Again, up to and including heat stroke, which can be a fatal condition, but kind of down at the at the lower end, we've got heat rash and sunburn, if you've been out in the sun, you've been out in the heat, probably familiar with both of those. Not a lot you can do about it. Keep the area dry, apply powders. There was a question on LinkedIn. There was a LinkedIn post by a safety professional the other day, who really kind of got hammered on the question. And her question was, I wish I would have saved the post. I'd throw it up exactly. But her question was, should companies provide sunscreen to their workers that are working out on in the construction industry, in the field, agriculture industry, out there in the field and exposed to the sun? And there were many commenters who said, yes, that's a hazard, and you should do things to protect your employees from hazards. You should give them sunscreen. But there were also quite a few people who wrote back and said, absolutely not. That's a personal thing. What if they're allergic to sunscreen? I thought it was just kind of an interesting discussion. And if you've got any thoughts on that, I'd love to hear what you think about employers providing sunscreen to their employees when they work out in the sun. I know my clients do, or at least I encourage them to do that. It's clearly a hazard. Sunburns are uncomfortable. They're no fun. They also lead to skin cancer. I think providing sunscreen encourages its use and is a good idea, but love to hear what you all think as well. After that, we start to get into a little more severe types of heat illnesses, heat cramps being the next item. And, heat cramps is still a manageable condition. When somebody's experiencing heat cramps, kind of, doubled over, they've got those cramps in their side. The first thing we really want to try and do is get them out of the heat, encourage them to rest for a minute, drink water, and a carbohydrate electrolyte replacement drink, a sports drink, if you will. And I'm going to talk about those a little more in just a few minutes. But the other thing that we want to do when somebody has heat cramps is monitor them for additional signs of heat stress, which is kind of the next condition. Some people will call heat stress. Some people will call heat exhaustion. This is really starting to be a serious condition. You need to absolutely remove a person that's experiencing heat stress or heat exhaustion from the work area. Try and take off some of those additional layers. We wear a lot of personal protective equipment in construction. Get those hard hats off, get those safety vests off, definitely give them fluids, start to apply some cold packs, and then monitor for heat stroke. Which is really important. Heat stroke is basically when the body's core temperature begins to rise uncontrollably. So it goes past 104 degrees, hits 105 degrees. We're moving on into 106 degrees Fahrenheit for your core body temperature. And at that point, the body just loses its ability to cool itself down. And you're basically cooking your internal organs. The heart's working so hard that you're at risk of cardiac arrest. Somebody that's experiencing heat stroke, and the signs for this would be things like they're disoriented, they've fainted or passed out. They could be sweating profusely, or they might have stopped sweating altogether. It's really hard to actually determine the difference between heat stress or heat exhaustion and heat stroke. The real measure is, what is their core body temperature? If you can take their their body temperature, or even sometimes their skin temperature, although that can be a little misleading. If it's up there 102, 103 degrees, they're moving into a heat stroke condition. That's absolutely a medical emergency. First aid for this includes things like apply ice packs, pour cold water over their head, do anything you can to start to bring their temperature down. But the biggest thing that you have to do for heat stroke, and one of the things I want to make sure everybody takes away from this, is heat stroke is an absolute medical emergency. If it's not treated at a hospital, it absolutely can lead to fatality. I've had a couple of clients I've talked to talk about some employees on projects experiencing heat stroke. Again, we're looking at temperatures of 117 degrees today in my part of the world, and I haven't seen any fatalities here in my part of the world for at least in construction for the last couple of years, but we've definitely had some very serious heat stroke incidents where people have ended up in a coma and in the hospital for weeks at a time. It's very serious condition. So you want to learn more about, all the signs and symptoms of heat-related illnesses. Again, I've got that course in there in LinkedIn Learning. I'll throw a link into the chat later after I'm done live streaming here that'll unlock that course for you for 24 hours, give you plenty of time to watch it, and you can learn more about some of those conditions. For today, I want to kind of move into how the body gets rid of heat and what we can do to help it, because this is where some of the technology and maybe some of the new innovations in the construction industry come into play. So the body really has four mechanisms of getting rid of heat. Those are conduction, evaporation, radiation, and convection. And I want to take a look at each one of those and what we can do out in the field to assist with each one of those mechanisms and help our body get rid of heat. So the first one, conduction. We've seen some innovations in the industry related to helping the body get rid of heat through conduction. One of the biggest things I've seen is we have some of these medical kits now, or first aid kits, that are labeled as heat stress kits, and they have cold packs in these heat stress kits. And the cold packs aren't really just a place on the forehead or wherever you feel hot. The cold packs really, to be effective, should be strategically placed near the large veins in the body, because that's where the most blood is flowing and that's where the most heat exists. So if you can use the cold packs, put them against the skin, so your arteries here in your neck, under your arms, down in your legs by the groin area, where you've got these large blood vessels, these large arterial arteries, and you can use the cold packs to help draw away heat. They really can have an effect and can really help somebody that's experiencing heat exhaustion and heat stroke, and kind of get them back out of the danger area so that they don't progress to heat stroke. Some of the other things I've seen I haven't seen used in construction, but again, it's so hot out here that we have some fast food restaurants that have people outside taking orders in the drive-through lines, and I've seen some of them using safety vests that they're needing to wear because they're out there in traffic, but safety vests with cold packs in them kind of help do the same thing, rid the body of heat. Yes, the cold helps you feel better, it cools you off a little bit, but you're also helping to draw that heat out of your body's core. Haven't seen anybody use those in construction. Might be a little bulky. I don't know. Again, if anybody has seen that in construction, like to see that there in the comments. Let's see. I've got one comment here. Our country stopped work today during the peak hours of heat weather for 3 months to avoid heat stroke. June, July, September. I think it's a major part of protecting the labor and the workforce in construction. I couldn't agree more. I know several of my clients will stop work at noon today. I talked to the safety manager of one of the large roofing companies out here, and they sent a memo out to all their employees that directs them to stop work at noon today, actually for the rest of the week until we see what the heat's doing. Obviously, if you're a safety professional and you look at the hierarchy of controls, getting rid of the hazard is the best thing we can do. And in this case, that equates to, getting people out of the heat before the heat of the day gets to the point where it's just too much for our bodies. So, good comment. I think that's really important. I think we had another comment here. Same thing. Most of the countries here in the Middle East used to provide 3 or 4 hours of summer break during the day, which time lasts for 4 months, even though electrolytes are also provided. One of the mantras that we have when we talk about working in the heat is water, rest, and shade. those are just really important to allow your body. We work hard in construction. It's strenuous. We wear a lot of layers, which doesn't help. We wear hard hats, which prevents a lot of the heat from escaping out of our head. So that rest time, those resting periods throughout the day, I think are just really important. And I have seen a lot of construction companies here in my area really start to do a much better job in the last few years of putting up like the pop-up shade structures, and giving people an area where they can get out of the heat as much as possible, get into some shade, get into an area where they don't need to wear their personal protective equipment. They can get rid of those vests, those hard hats, strip some of that off and just drink some water and allow their body to cool down for a little while. And I do think that's very important. So great comments there. Going back to the slide I had up there, the next way our body gets rid of heat is through, we have evaporation, radiation, and convection. Those were kind of the three that are left. And, I have seen, see if I can throw a video or two up here. I have seen some more use of job site fans, which I think is just outstanding. I think it's great to see these on jobs. I really see these on a lot of the larger projects, on all the levels. We're starting to put these out. The rental companies have them now. Some of the larger general contractors keep these as part of their equipment inventory. And that kind of goes back to that convection. In my area, one of the additional problems we have with the heat is that we don't have a lot of wind. I'm kind of looking outside and none of the leaves on the trees are blowing at all. It's just completely calm. And that means that we're not getting that convection, that breeze blowing across the skin that helps the sweat evaporate and helps cool our bodies off. And so those fans can really be something that helps rid our body of heat. And it's nice to see those along with the pop-up shade structures being used out on our projects. So as just if on cue here, I have a comment from Arvin. Acclimatization would also be a major factor in controlling heat stress cases. And this is absolutely true. Now I don't have to figure out how to get my next slide up on the screen. My next slide was acclimatization. So thank you for the comment. Acclimatization, if you're not familiar with the term, is just simply getting a person used to working in the heat. That sounds kind of silly to some people, but it is absolutely a real thing. There have been plenty of studies throughout the world to prove that the body actually does acclimatize itself to working in the heat, and that somebody that is not acclimatized is much more susceptible to heat stress or heat stroke than somebody that is acclimatized. So getting acclimatized to working in the heat is extremely important. Most of the studies would recommend something like a 2-week break-in period, where for the first 2 weeks of somebody being exposed to these extreme temperatures, we give them probably twice as many breaks as they would normally have. We increase the lengths of the breaks, and we really keep an eye on them. We do things like assign, use a buddy system, make sure nobody ever works alone out in the heat. And again, for the first 2 weeks, I think this is really important as the body gets acclimatized to that heat. So, a couple of things happen. Number one, here in my area, we've had a nice moderate spring. We've had great temperatures, and we sort of went from, being really nice outside to this week it's 117 degrees out. And that means that almost nobody is acclimatized. It's been since last summer since we've worked in the heat. So now is the time to be really careful. The other time I think that acclimatization is really important is when we bring in new workers. We get a lot of people that come from other industries into construction. And, even if you've worked in a hot warehouse, you've done manual labor, you've done things that, require you to exert yourself throughout the day. If you haven't done it in construction and you haven't been outside in that direct sunlight where you just can't get away from it, and you got that hard hat on, the helmet on, the safety vest, it can really be a shocker. And so we really need to do everything we can to take those new workers and spend at least a couple of weeks getting them acclimatized. So thank you for the comment, Arvin. I appreciate that. That's really important. Let's move on to a couple of other we'll call them technology type items that can help us protect people that are working in the heat. One of the things that I started doing about 4 or 5 years ago, I had a couple clients call and say, look, can you come up with a more objective way for us to categorize the heat hazard throughout the day? Is it low? Is it moderate? Is it high? At what point, what's our cutoff point? At what point do we say we just should not be working out here for the rest of the day? There's got to be a way to come up with some objective criteria. I looked at that and said, well, certainly there's got to be ways to do that. But we've got to do things then look at more than just the temperature, because humidity plays a huge role in heat-related illnesses. So when it's really humid out, our body still sweats, but since that sweat doesn't, we perspire, and since that perspiration does not evaporate and cool our skin, our body just continues to perspire out there in that humidity, and we lose too much bodily fluid, and we just completely lose the ability to cool down. So even in temperatures that, again, for me, I wouldn't consider extreme, like 90 degrees, if you also have 50% humidity, that is really dangerous. That's really hazardous. When it's 90 degrees here in my part of the world, I usually have 10% humidity. And I'm still in a moderate hazard category, but I can do things to manage that, water, rest, and shade, break schedules, and keep people safe. But in that same 90 degrees and 50% humidity, it starts to get really hazardous. So, it's got to be some combination of heat, humidity, and then things like, working out there in the direct sun where we have radiant heat coming off the concrete slabs or the asphalt roadway, that increases the risk. So, how do we put all these things together and come up with some objective criteria? One of the things I introduced in my course, my heat awareness course on LinkedIn Learning, is I brought in a document from the CDC, NIOSH, which is a division of the CDC, that talks about using the heat index. Actually, it talks about two things. It talks about, one, using something called the WGBT, or wet bulb globe temperature, WBGT, wet bulb globe temperature, to determine heat stress. And I'll throw up just a little video here. We'll just kind of let this run through. Wet bulb globe temperature is something that takes into account the ambient temperature outside, so the temperature that you would read on a thermometer. It also takes into account humidity. It takes into account wind speed, and then it takes into account radiant heat. So again, if I'm standing on a roof, if I'm doing work on a roof and I've got a white reflective membrane that is reflecting all that heat from the sun up at me, I'm much more susceptible to heat stress than I am if I'm down inside the building in the shade. And so this wet bulb globe temperature is something that actually military organizations, professional athletic organizations, and now we're even seeing many high school athletic organizations use this wet bulb globe temperature to really accurately determine the heat stress factor right where you're working. And if you're in the concrete industry, there's plenty of these instruments. The one I just threw up there was from Kestrel. And the reason I threw that up there is because if you're in the concrete industry, you maybe are used to those little instruments from Kestrel that measure humidity, temperature, and wind speed, because we use those to determine the probability of getting shrinkage cracks when we're pouring large slabs out in the heat and the sun. So Kestrel is kind of a common name in the concrete industry. But they also make these heat stress meters, and you saw that little bulb on the top, and that helps it gather all of this information. Again, it's heat, it's humidity, it's radiant heat, it's wind speed, and it puts it into a calculation that calculates the WBGT, the wet bulb globe temperature, and from there we can put that into a calculator. And I just pulled up the one from OSHA here that you see on the screen. Should be able to get to this anywhere in the world. It's osha.gov/heat-exposure/calendar. And I put these links in the chat on both the event and the LinkedIn Learning chat. So you should be able to get to these after the live stream. And if you have any questions, you can add them in the comments and message me later. But osha.gov/heat-exposure/calculator. And what this allows you to do is actually produce a very precise determination of whether or not you should be working outside or not. Again, in order to do this, you have to get the WBGT value, which is much different than the temperature. It's much different than even the heat index that I'm going to talk about in a minute. The only way you can really accurately get that value is to use one of those instruments like I just showed you. And there's plenty of them out there. They cost they cost several $100s. They take a little bit of knowledge to be able to use. But if you can get that and you can punch some of those values in. So let's say my WBGT is 78, which is fairly high. And then this calculator actually lets us put in the workload: light, moderate, heavy, or very heavy. So I'm going to say we know we're out in the heat. We're trying to regulate heavy work. We're just going to do moderate work. And this does pull in the acclimatization factor. Are they acclimatized or are they unacclimatized? We'll select acclimatized. Are they in normal work clothing? I'm going to say they're in a double layer of clothing because we've made them wear vests. And so they've got hard hats on. We'll put double layer of clothing. And then it even asks for their body weight, normal weight, or overweight. And we'll click on submit. So in this case, we'll see heat stress is above the limits. And in this calculator and in the logic that it's using to determine this, what this means is that if all of these factors were true out on your job site right now, the objective thing to do would be to stop work. You could also look at things like, could we just limit the moderate work? Could we limit everything to light work? And you see that does get the heat stress below limits for acclimatized workers. But even for unacclimatized workers, if I change that and keep the workload at light, heat stress is still above limits. So this is a way to quickly determine whether or not you should be working out there in the heat or not. And again, this is based on I think it's a 250-page document from the CDC and NIOSH. And quite a bit of research. It's a very accurate determination. And again, this is we do see this being used by professional sports organizations, right? They want to protect their athletes, but they still want to train them, and they'll use this type of measurement and calculation to determine whether or not they should be training out there in the heat. So I've got a question here again from Arvin. What's the difference between WGBT index reading and heat index reading? Which is more feasible to base the stop work on? And again, Arvind, thank you. You're just sort of queuing these things right up for me in the order I wanted to do them in. I really appreciate it, because heat index is really what I'm going to talk about next. So one of the limitations of using the method that I just showed you is, again, you've got to have that instrument. It doesn't cost a fortune, but it does cost several $100s. You do have to have somebody that knows how to use it. So there's a little bit of training involved. And you've got to have the instrument protected out there, right? And somebody's got to go check it and kind of run the calculations. Now, the particular instrument I showed you, I think, has those calculations built in, and it'll tell you whether you're above or below the limits. But nonetheless, it kind of requires some constant checking throughout the day. Now, if I were working in an area where we had real high heat, real high humidity, and I was doing things like roofing. Again, I'll use my example, working on a 500,000 square foot warehouse. A couple summers ago, I had, at any given time, 30 to 40 people up there on this roof working on mechanical and skylights and roofing membrane. And at the same time, that white reflective roofing membrane was down. Just using the heat index was really not the right way to go, and we did a little experimentation. We used the heat index for a given day at like noon, middle of the day, and that told us we were in a high hazard category, but not extreme. But then we used the WGBT measurement, put a device up on the roof, which again took into account the fact that there was no breeze and that we had all this radiant heat coming off the roof, and that told us that at noon we were in extreme danger and nobody should be working up there. So there are times when I think each is appropriate. The heat index that I'm going to show you here in a minute, I think is much easier to use. Let me cut over to that page and zoom in. Heat index is that value that you see the weather people give you on TV and the news. Sometimes they call it the feels like index. And most of the time, that's just a measure of air temperature combined with relative humidity. So let's look at what I think I have out here in Arizona today, which is 117 degrees is what it's going to be in the hottest part of the day. And for some reason, those numbers aren't popping up on your screen, but I type 117 degrees into that box. Let's see if I can reset this here and pull that up for you. And the relative humidity I have out here is only about 10% humidity. And so when I calculate that, and I'm sorry if that's not showing up on your screen, what I get is that the heat index, or the feels like heat score, is actually 112 degrees. So the fact that I have very low humidity brings my heat index down to 112, as opposed to just looking at the temperature of 117. Now, by the same token, if I only have a temperature of about 105 degrees out, but my relative humidity is 50%, now my heat index goes up to 134, or it feels like it's 134 degrees out. And obviously, that's probably way, way too hot. So using that heat index, let me throw up another screen here. Using that heat index, we can create some objective hazard categories. And again, these are based on some research out of the CDC and NIOSH, which determines some cutoff points using the heat index. Now, one of the things that you need to understand about the heat index, the feels like index, is that very simple calculation where we combine temperature with humidity assumes that a person is doing very light work in the shade with a little bit of a breeze. So again, these are not factors that we tend to see in construction. We tend to be doing moderate to heavy work. We're probably out there in the direct sunlight. So the cutoff values that you see here, where the danger is low, moderate, high, or extreme, may be different than what, say, the National Weather Service publishes. These have been adjusted for use in construction, and these are the suggested values, the suggested heat hazard categories based on the heat index that you can easily obtain from your weather service. If it's 91 degrees or lower, and I'm sorry, I should have converted these to Celsius as well, but if these are Fahrenheit, so if it's 91 or lower, you're in a very low heat hazard category, just basic health and safety planning. If the index is 91 to 103, you're in a moderate category, and you need to start implementing precautions, heightened awareness, really starting to implement that water, rest, and shade mantra there. If you go past that, you go 103 to 115, you're in a high heat hazard category, and you really need to start deliberately on a scheduled basis checking on people out in the field, enforcing those break schedules, enforcing the water consumption throughout the day to keep them safe. Once we go past that, to 100, past 115 degrees based on the heat index. Now our hazard category is extreme. And the suggestion there, or the recommendation there, is when you hit this extreme category, you really should stop work. Now, there are times where we have critical work that can't be stopped. And again, if you look at my class, or you look at some of the documentation that's out there that NIOSH or OSHA has published, they'll give you recommendations for, okay, if you absolutely can't stop work and you have to work in that extreme hazard category, these are the additional things that you need to do. And the key thing that they say that we need to be doing if you're going to continue to work in those extreme hazard categories is you have to have somebody who's medically qualified to check on people at regular intervals, depending on how strenuous their work is. So in other words, you really got to be able to monitor their vital signs, their blood pressure, their core body temperature. So again, the recommendation there is just stop work. It's extremely hazardous. Reschedule the work for early morning so that you're done when the temperature reaches these extremes. So again, Arvin, hope that answered your question. There's a big difference between the WGBT index and the heat index. And just looking back at those cutoff scores, so using the heat index, the cutoff would be 115 degrees Fahrenheit to put you into that extreme category. Using the WBGT value, that would be more like 80. So, very different values. So make sure you use the right cutoff values depending on whether you're using WBGT or heat index. Heat index is going to be, again, just easier to find. Doesn't require any special instruments. Pretty easy thing to get. And the last thing I want to show you, again, just another piece of technology, if I can get it up on the screen, is this is again from NIOSH. This is the NIOSH Heat Hazard app, and it's available for Android and iOS. And you'll see it here. What it does is it actually uses your phone's GPS. It pulls in the weather conditions for your area. So right now I'm sitting at 99 degrees. It's not even 10 o'clock in the morning yet. I'm sitting at 99 degrees with 18% humidity. And it shows me that I'm in the moderate risk category. And I believe so. I know that this app is available outside the US. I had a friend of mine in the UK make sure that he was able to download it. So I know the app is available, should be available, again, for iOS or Android worldwide. I think that it only pulls in the weather data automatically in the US because it pulls it from the National Weather Service. But it does give you the ability to go input your own values. So later today, I'm going to be 117, and we'll say the humidity is going to be the same. And you see that puts me right up into the extreme risk category it feels like it's 122 degrees out. So you can manually input this, and that way all you need to do is get the humidity and the temperature for your area and still use this app. And I just think it's kind of interesting to play around with, even if I take it down to 100 degrees. But I input 50% humidity, still throws me up into that extreme risk category. So let's see, let's do a couple more examples. There is a way in here to switch this to Celsius, by the way, but if I just go back to 117 degrees and probably about 15% humidity that we're going to look at today, once we reach those temperatures, I'll be in the extreme risk category. We really should not be working out in the heat. One of the things that I also wanted to show you on this app, though, is the hourly predictions. And now, of course, the app is not going to cooperate with me. There we go. If you're able to pull in the temperature and weather information based on your GPS, you can click this hourly button, and the app allows you to actually plan your day. So 10 o'clock, 11 o'clock, I'm still going to be in that moderate risk category. But by noon, I'm jumping into that high risk category. 1 and 2 o'clock, I'm up in that high risk category. So I think that hourly feature is really cool, because you can look at it in the morning for your job site and really kind of plan the day and say, yeah, by noon, we're going to be in the extreme category and everybody has to stop work. In this case today, after 11 o'clock, somewhere around noon, we're going to be in the high risk category. And if you're going to keep working, then we need to implement some mandated break schedules for water, rest, shade. The other nice thing about this app is that all of the precautions that you should be taking at these different risk categories are right there in the app. You just click on the button and it tells you what you should be doing in that particular risk category. So great information. Also has all of the signs and symptoms for heat stroke, heat exhaustion, heat cramps, and so on, along with the first aid information there. So a lot of really great information in this app. I think it's a great app to use. I really encourage everybody to use this, particularly in the US. It's nice that it pulls in the weather data automatically for you. A question here, what's the name of the application to use in my area? So let me see if I can pull up the website there. Well, I don't seem to be able to find the website. The name of the application, if I let's see if I can go into the store. It's not going to cooperate. The name of the application is just NIOSH Heat Application. It should be listed that way in both iOS and Android. Again, the publisher is NIOSH, and it's heat application or heat stress application. So you should be able to find that pretty easily in either store. And I do have a link to those pages, again, in the comments and in the events page that went along with this live stream. So you should be able to find it there as well. All right. Last thing I want to look at, again, I'm kind of going on the theme of what's new out there in heat stress and heat awareness. So the app, I think, is one of those things that's new. Being aware that there's that instrument out there that measures wet bulb globe temperature and takes into account wind speed, radiant heat, and that kind of thing, I think is new and important. Take a look at that. And the last thing that I really want to look at, if I can cut over, are sport drinks. Okay, now sport drinks aren't new. We call these the electrolyte replacement drinks. Sport drinks are not soda. I threw this page up there. I'll tell you why in just a minute. But this one compared this particular product, which is called Working Athlete. It's a newer product. I see it in use on our construction sites here in Arizona all the time. And it compares their product with soda, which you should absolutely not be drinking, Squincher and Gatorade, which are kind of the two that have been out there for a long time, right? Everybody knows about Gatorade as a hydration tool and electrolyte replacement. But some of these things like Gatorade, like Squincher, you see are really high in sugar. So they've gotten, they've had some kind of negative press because people overdrink them. And when you're going to drink things like this Gatorade and Squincher, it's because there's so much sugar. They've got a lot of calories. They have a lot of sodium, but not necessarily a lot of potassium. They do have some potassium, which your body needs. My rule of thumb is drink a Gatorade for every 4 glasses of water that you're drinking. Kind of that 1-to-4 ratio. If you're really sweating a lot, it's really humid out, you're really doing strenuous activity, then maybe it's every other. But those have been out there for a while. I really wanted to look at these newer products. Again, this one is called Working Athlete. And the difference here is it has a lot less sugar, a lot less calories. It's got a lot less salt, but a lot more potassium. And, you can look at their website and they go through the science behind that. They also throw in some vitamin C, some of these other things that they claim help you hydrate faster. So again, I would call these hydration aids. You see there in the picture, it's a tube, you add it to your bottle of water, and it's just supposed to help you hydrate faster than drinking water alone, and actually does a little better job than like the Squincher or the Gatorade. And there's probably many more of these products out there. Working Athlete is just the one that I happen to see out there in my area. Now, I want to differentiate that, though, between that and a couple of products that I see out there on the market. One is called H2ORS, and the other one that I actually see in grocery stores and warehouse stores now is called Liquid IV. These two are a little bit different. Number one, these don't taste very good from what I remember. And they're not meant to taste very good. They're not meant to be added to every bottle of water you drink. As the name Liquid IV would sort of suggest, these are a little bit different than the hydration aids. These are actually very much based in science. There's a lot of research behind them through the World Health Organization. These are oral rehydration solutions. And they can, for somebody that's experiencing, I'm going to say like up to moderate dehydration. So they're kind of experiencing some heat exhaustion, moderately dehydrated. These things, these like Liquid IV, or the other one I said was called H2ORS, can be given to have them very rapidly replace electrolytes and fluid in their body. And I've even talked to a couple of emergency medical doctors, industrial medicine doctors that say that they'll, somebody that they see that's up to about moderately dehydrated, they'll give them 1 or 2 of these before they give them an IV, and they'll usually recover without IV fluids. So I think those are interesting. I think that it's something that we can look at using out in the field as a first aid measure. I'll just sort of leave you with the fact that if somebody is experiencing heat stroke, that's still a medical emergency. That still is going to require IV fluids, and something like these liquid IVs are absolutely not a replacement. Somebody that's experiencing heat stroke needs medical care in a hospital if they're going to recover. So don't overuse these products. Don't think that they're a replacement for IVs just because the name is Liquid IV. Although, like I say, I've heard from some doctors that say that they really can be used in place of IV solutions for somebody that's moderately dehydrated, certainly not severely dehydrated, and certainly not experiencing heat stroke. All right. See if we have any more comments up here. Thanks for the valuable information. How can I contact you to ask your advice about another topic in the construction management, if possible? So that's probably a good way to end. I'm going to throw a couple things up here on the screen. This is my LinkedIn profile. This is the best way to get a hold of me. You can check my profile and find all my courses there. My posts deal with construction management topics. You can follow me to make sure you see those. You can also message me with questions either directly here on my LinkedIn profile, or if you are one of those people that watch the LinkedIn Learning courses, I really encourage you to use the Q&A feature in those LinkedIn Learning courses. That's a great way for you to ask questions that get brought right to me, but also everybody else in the course is seeing them. So it's a great way to start discussions. So again, linkedin.com/in/RogersGym is my LinkedIn profile. If you have questions for me, that's the best way to find me. I will also continue to do these live streams every Wednesday morning, 9 a.m. Pacific. And moving forward, we'll be looking at some additional types of personal protective equipment, some additional technology items. I think we'll switch week from week, maybe safety topics one week, construction management topics another week. But next week, I'm gonna be talking about analytics and data in construction. I'm going to have another LinkedIn Learning instructor, Robin Hunt, join me. Robin is an expert on data analytics, and she has a fair number of construction industry clients. And as we see apps like PlanGrid, FieldWire, Procore that allow us to collect more data in the field, people like Robin are coming in and telling us, hey, now that you've got all these data points, here's what you can do with them. We can really use data to help improve quality, improve safety, improve productivity. So that's what I'm going to be talking about next week here on my live stream. Again, it's next Wednesday, every Wednesday, 9 a.m. Pacific, but specifically next week, we'll have Robin Hunt on the show. We'll talk about data and analytics in construction. Looking forward to that. Hope you join us next week. Thanks for joining me today. Again, if you have any additional questions, ask them in the chat. I always keep an eye on that for a couple of days after the live stream, and happy to reply. Thanks for joining. Hope to see you next week.